This video tutorial will go through the solutions to Assignment 2 on inequalities. We begin with question 1. Without the use of a graphic calculator, find the range of values of x such that x squared takes 7x plus 12 is less than 0. We'll move on to the next part later. Let's do this part first. I want x squared take 7x plus 12 to be less than 0. Well, I can factorize this to be x take 3, x take 4 to be less than 0. So, what do I have? I've got I've got a product of two numbers that is negative. That means basically one of them has to be negative. Let's do this using the number line method then. The critical points along my number line are 3 and 4. I also know that this is a parabola, so it's going to, and it's a positive parabola, so it's going to be a smiley curve, so it's going to look something like this. And I'm interested in the area where this whole thing here is less than 0. So I want this part of the curve in here between 3 and 4. So therefore 3 is less than x is less than 4. And sorry, I've copied that wrong. This should be less than equal to. So this 3 is less than or equal to x is less than or equal to 4. The second part tells us hence. Now when we see hence, that means that we must use what we had from our previous part. We must use it. So hence deduce the range of values of x satisfying the following inequalities. X squared plus 7x plus 12 is less than or equal to 0. So x squared plus 7x plus 12 is less than or equal to 0. Now, we could solve this exactly the same way and it wouldn't be that hard. But we want to know, we were told to do it using our previous part because it was hence. So we try, consider x squared minus 7x plus 12 less than or equal to 0, our first part, and we replace x by negative x. So we get negative x squared minus 7 times negative x plus 12 is less than or equal to 0. Or in other words, x squared plus 7x plus 12 less than or equal to 0, which is what we have. So therefore the solution to this is just going to be 3 is less than or equal to negative x is less than or equal to 4. And if we solve these independently or solve them together, we're going to get negative 4 is less than or equal to x is less than or equal to negative 3. Part B wants us to do something similar, so hence deduce the solution to this one. And we can see, if we consider, so it's 4x squared take 14x plus 12. So 4x squared plus 14x, minus 14x plus 12 less than or equal to 0. And we can see, if we consider x squared minus 7x plus 12 less than or equal to 0, and we replace x by 2x, what would we get? We would get 2x squared minus 7 times 2x plus 12, which is exactly what we want, 4x squared minus 14x plus 12 less than or equal to 0. So we can replace x with 2x in our solution as well. So therefore we have 3 less than or equal to 2x, which is less than or equal to 4, which is our hence part. And so 3 over 2 is less than or equal to x is less than or equal to 2. So that deals with question 1. Question 2. Given that y is equal to 2x squared plus px plus 16, and that y is less than 0 only when x is between 2 and k, find the values of p and k. So we know that y is equal to 2x squared. That's a terrible squared, sorry. Get rid of that. Yep, sorry. 2x squared plus px plus 16. And we know that y is less than 0 only when 2 is less than x is less than k. So this means that y equals to 0 when x is 2 or x is k. So let's first of all use x is 2, y is 0. So if we call this equation 1, we're going to sub 2, 0 into 1. And what do we get? We get 0 is equal to 2 times 2 squared plus p times 2 plus 16. And so we get 0 is equal to 8 plus 16 plus 2p. P is going to be negative 12. So therefore, our equation is y is equal to 2x squared take 12x plus 16. And we're going to sub in x equals to k, y equals to 0. Or rather, sub k 0. And this is going to be 2 into 2. And what do we get? Well, we get 0 is equal to 2k squared take 12k plus 16. So if we solve this one, well, this is actually just 0 is equal to k squared take 6k plus 8. And so this is 0 is equal to k take 2, k take 4, k equals to 2, or k equals to 4. And I can reject k equals to 2, because if we look at this, k is strictly bigger than 2, so k equals to 4 is my answer. So p equals to negative 12, k is equal to 4. The last part wants us to solve this inequality. X plus 3 over 2x take 1 whole thing squared is less than 1. So let's do it. X plus 3 over 2x take 1. Is it x plus 3? Yes. Whole thing squared less than 1. Now you can certainly do this graphically, but because I'm dealing with a square, I know something very nice about everything on this left hand side. I know that it must all be positive because I've squared it. So that means I can do nice things like cross multiplying. So this basically means that x plus 3 squared should be less than 2x take 1 squared. X squared plus 6x plus 9 is less than 4x squared take 4x plus 1. Let's move everything to one side of the equation. I get 0 is less than 3x squared take 10x minus 8. And if I look at a solution to this, to where this happens from GC or however, actually I don't even need to use a GC, do I? This is 0 is less than 3x plus 2, and then x take 4. Right. And so now I can work this out the same way as I did last time. What are my critical points? Where does this equal to 0? Well, it equals to 0 at negative 2 over 3 and at 4. And again, it's a happy parabola. So it's going to look something like that. And I want the areas where it's above the x-axis. That is, I want the areas where it's bigger than 0. So that's going to be over here and over here. So my answer is going to be x has to be less than negative 2 over 3, or x has to be bigger than 4. Now, there's something you also should check. If you look back at this original equation, we need to make sure that x equals to a half is not in our solutions. Because if I substituted in x equals to a half, then this whole thing would be undefined. But what you see is x equals to a half is somewhere about here, I think. And quite clearly, it doesn't fall within our range of solutions. So x doesn't equal to half, but we don't need to do any extra further work. So just this is our final answer. And that is the solutions to assignment 2.